Hey everyone, welcome to the first session in this series of ordinary differential equation, right? So as you all know how to solve a linear differential equation of first order and first degree, we have already covered all these in our school syllabus. Now in this series we are going to see how to solve a exact differential equation of first order but not the first degree, then orthogonal trajectory, linear differential equations with constant coefficient, then homogeneous differential equation, linear differential equation of second order. Here the coefficients will be variable and we will see various methods to solve, like method of variation of parameters, method of undetermined coefficient and all these. After that we will move to ordinary simultaneous equation, where simultaneous system of equation will be given to us and we will solve them. After that, total differential equation. We will cover all these topics one by one. Okay, so if you want to practice questions, you can visit the website creatologics.com, where you will find the tests and quizzes and you can attempt all them, right? If you need any help, you can contact me on this number. Okay, so let's move on to our topic. Here we are going to cover exact differential equation, and if the given differential equation is exact, how to find its solution. So we will cover these two topics in this session. Okay, so let's see what do you mean by exact differential equation. See, if you have an differential equation m dx plus n dy is equal to 0, this is your given differential equation. This is said to be an exact differential equation if and only if the partial derivative of m with respect to y becomes equal to partial derivative of n with respect to x. If these two are equal, where m and n you can see here, if these two are equal, then you say your given differential equation will be exact. If these two are not equal, then differential equation is not exact. Sometimes we will find an integrating factor and we will multiply the given differential equation by that integrating factor to make it exact. But we will see all these things in the later sessions. Okay, so let's take an example where we have this one. You need to find the value of alpha for which the differential equation which is given to us becomes an exact differential equation. So as you all know, if this differential equation will be exact if the partial derivative of this, which we can say m. So partial derivative of this with respect to y, and it becomes equal to partial derivative of this, let's say n, partial derivative of n with respect to x. If these two becomes equal, we say differential equation will be exact. Okay, but here it is already given that differential equation is exact. You need to find the value of alpha for that. Say m is equal to, we have 1 plus x square y cube plus alpha times x square y square, and also we have n is equal to 2 plus x cube y square plus x cube y. Now partially differentiate this m with respect to y. It means you have to keep x constant. Consider your x as constant and differentiate it with respect to y. So we get 0 plus, if you differentiate this with respect to y, you get 3y square and x square is same, so 3x square y square, plus here you get y square is differentiated, gives you 2y. It means you can write it as 2 alpha x square y. Now partial differentiate of this with respect to x, keeping the y as constant. So differentiation of 2 is 0, then differentiation of x cube y square, your y square is constant, so derivative of 3, this one 3x square y square same, x cube y, its derivative will be 3x square y. Okay, so it is given to us that these two are equal because it is exact. It means make them equal, equate them, you will get 3x square y square will get cancelled with 3x square y square, and you are left with 2 alpha x square y is equal to 3x square y. Since my x and y are non-zero, my x and y are non-zero, right? Not always 0, okay? So I can remove them. I will get 2 alpha is equal to 3. I get alpha is equal to 3 by 2. So from these options you can see the option B is correct. Okay. Now let's move on to the next part where a differential equation which is exact is given to us. Say m dx plus n dy is equal to 0. Say this equation is exact already. We have shown this. Now you need to find its solution, and the solution of this differential equation is given by integration of m dx, keeping y constant. Here you have to keep y as constant and integrate with respect to x, plus integration of not full n but the terms of n that do not contain x in it. Do not contain x, dy is equal to c, where c is your constant of integration. It will be our solution. Okay, so you have to remember this. It's very easy. Let's take an example and see how to solve such equations. Say we have 1 plus e raised to the power x upon y dx plus e raised to the power x upon y times 1 minus x upon y dy is equal to 0. This equation, which is differential equation, this can also be solved by various other methods, like by using the homogeneous differential equation method, where you put your x upon y is equal to t. You can solve it by that method also, but here we are going to use the exact differential equation method. So first we have to show that this differential equation is exact. So let's take m. What is m here? M is this 1 plus e raised to the power x upon y. Now partially differentiate it with respect to y, keeping x constant. So derivative of 1 is 0 plus, now derivative of e raised to the power x upon y, which comes out to be e raised to the power x upon y, same, then derivative of x upon y with respect to y. What will be the derivative of x upon y with respect to y? It will be minus of x upon y square. This one. And now what is n? That was e raised to the power x upon y times 1 minus x upon y. Now partially differentiate this with respect to x. Now we have to use the product rule here because two functions are in multiplication, right? So use the product rule. Keep e raised to the power x upon y same and differentiate this 1 minus x upon y partially with respect to x. So I will get 0 minus 1 upon y. Now plus sign. Now keep this 1 minus x upon y same and differentiate this e raised to the power x upon y. I will get e raised to the power x upon y into derivative of x upon y with respect to x. So I get 1 upon y only, keeping the y constant. So let's further simplify this. I get e raised to the power x upon y divided by y, and from this part I get e raised to the power x upon y by y minus x upon y square e raised to the power x upon y. So this will get cancelled with this one, and you can see this is coming out to be equal same as this one. So partial derivative of m with respect to y becomes equal to partial derivative of n with respect to x. Okay, so given differential equation becomes exact, and we know if it is an exact differential equation, the solution is given by integration m dx, which is m1 plus e raised to the power x upon y dx, keeping y constant here. Remember this, y is constant here, plus terms of n that do not contain x. Can you find any term in this which may not contain x? No, there is no such term. All the terms will contain the x. It means this part is 0, dy is equal to c, where c is constant of integration. Now let's integrate this part only, 1 plus e raised to the power x upon y with respect to x, keeping y constant. So I get x plus integration of e raised to the power x upon y is given by e raised to the power x upon y divided by the coefficient of x, which is 1 upon y, is equal to c. If I further simplify this, I get x plus y times e raised to the power x upon y is equal to c is my final solution. Its general solution, right? Here c is constant of integration. Okay, so that's how we calculate the solution of exact differential equation. I hope you got all of this, right? So the final solution is this one, and I'm giving you an assignment problem. You have to try this question by yourself, right? So you can consider this as your m, you have to consider this as your n. Now partially differentiate them. If they becomes equal, then you can use the method of exact differential equation, right? You can find its solution. Okay, so in this session we have covered exact differential equation. What do you mean by exact differential equation and how to prove it? And then we have solved an exact differential equation. We have calculated the solution also. In the next session, we will move to finding the integrating factor. What is the meaning of the integrating factor and how to evaluate the integrating factors for a differential equation. Then we will see the solution of differential equation by making them exact differential equation. Okay, so we will meet you in the next session. Thank you for watching this. See you in the next part. Keep watching, keep learning.